For years, the industry defined AI coding assistants as models that suggest syntax, but a new OpenAI update shifts that toward a full execution system. This diagram shows Codex's original architecture. In 2025, it was a cloud-based agent trapped in a contained sandbox, limited to repository files and local tests. Blind to the broader operating system, developers faced constant friction jumping between separate tools to manage the actual software lifecycle. OpenAI frames the April 2026 update as the end of the autocomplete era. It rests on expanding to desktop environments, connecting external tools, and automating recurring tasks. The objective has changed. You are now commanding an agent to operate your entire development environment. This pivot suggests that generating code faster is no longer the primary goal. The new objective is removing the bottleneck of workflow fragmentation. This schematic illustrates the architectural breakout. Codex transitioned from a stateless agent in a box to an entity routing commands to external execution modules. It now possesses desktop capabilities, allowing it to command a cursor, click, and type within native macOS applications. This matrix shows how the agent operates across different surfaces. It can spin up an unauthenticated browser to conduct its own QA loops and verify visual UI alignments. It also has an expanded infrastructure reach, navigating complex project work trees and accessing live SSH environments. Codex now evaluates rendered visual output, commanding the cursor within the GUI to verify front-end changes or iterate on browser games. Codex actively integrates using over 90 plugins and the Model Context Protocol to connect to external tools like Slack, GitHub, and Figma. A critical part of this platform is operational memory, sitting between the raw executing engine and the external services. Operational memory allows engineering teams to package their specific standard operating procedures into repeatable skills and automated schedules. The shift moves AI from a localized productivity boost for a single developer toward a standardized operational asset for the entire team. Granting an agent control over a desktop environment or unattended workflows creates significant risk if tool calls fail. To support this, the GPT 5.2 Codex engine is optimized for highly reliable tool calling, native compaction, and advanced visual reasoning. This slide captures the metrics proving that reliability. The model achieves state-of-the-art results on SweetEng Pro and Terminal Bench 2.0. These benchmarks prove the agent can solve messy repository issues and execute raw terminal commands rather than just passing coding quizzes. Broad execution requires a rock-solid foundation, and GPT 5.2 provides the baseline dependability needed to trust the machine with real engineering work. This cycle diagram shows how these new capabilities snap together. Codex has moved past merely writing code into owning the full development lifecycle. It now handles non-coding phases like morning task triage, babysitting pull requests, addressing diff feedback, and running recurring release checklists. The ultimate goal of this workflow substrate is to replace fragmented developer tools with a single cross-surface layer that manages an idea all the way to shipped output. For developers, this shifts the focus away from grinding through line-by-line syntax writing and towards supervising multiple autonomous threads of execution. This comparison chart maps the new competitive paradigm, the rise of workflow shells. In this environment, Codex is competing with unified workspaces like Claude Code and Cursor to be the primary interface for software creation. OpenAI's official framing characterizes Codex as the teammate that operates the systems, tools, and processes required to ship software. The market war has evolved. Success in this landscape depends on providing the most dependable environment for delegating end-to-end software labor.